Hi, this is King of Review. Person A and Person B start from the same spot and walk along a track 400 meters in circumference in opposite direction. Person A walks at 40 meters per minute and Person B walks at 60 meters per minute. How far did Person A walk when they meet each other for the first time? So let's think about what's going on here. We have a circular track and the total distance around is 400 meters. Now Person A and B, they start at the same spot. Let's say they start right here. Person A walks this way and Person B walks this way. And at some point, they're going to meet right here. We want to know how far did Person A walk when they meet each other here for the first time. So what we want to do is set up two equations that represent this situation. But before we do that, we need to define what our variables are. So let's let x equal the distance that Person A walks. And let's let y equal the distance that Person B walks. So now, using these variables, let's come up with a couple of equations. Well, we see here that the total distance around the track is 400 meters. So we know that Person A and B together cover the entire distance of the track. So the distance that Person A walks, we're calling that x, plus the distance that Person B walks, that's y. We know that in total, those equal 400 meters. So there's our first equation. X plus y equals 400. The next thing that we want to do is consider the rates here. We know that the rate of Person A is 40 and the rate of Person B is 60 meters per minute. So if you remember, distance equals rate times time. And if we rearrange for time, we get time equals distance over rate. So the total amount of time that Person A and B are walking is going to be equal because they both start at the same time and they both meet here at the same time. So if we can figure out the time Person A walks, we can set that equal to the time Person B walks because they start at the same time and they end right here when they meet at the same time. So let's do that. Let's consider the time for Person A. So that's distance over rate. So what's the distance Person A walks? Well, we're calling that x. So x over the rate. The rate is 40. So we have x over 40. Another way of writing that is 1 over 40 times x. And this is going to be equal to the time Person B spends walking. Again, time equals distance over rate. The distance that Person B was walking, well, we're calling that y. So we have y over their rate, which is 60. Y over 60. Another way of writing that is 1 over 60 times y. So now we have our second equation. Now what I want to do is rearrange this so that the variables are on one side and we have a constant on the other. So I'm going to move the 1 over 60 times y to the left. I'll do that by subtracting it on both sides. So now I'm left with 1 over 40 times x minus 1 over 60 times y equals 0. And this is our second equation. So now we have two equations in our system. You can see that both of these equations are in the form ax plus by equals e and cx plus dy equals f. So this is a system here, a template for a system of equations, and you can see that our equations match this template. So we want to solve the system. That is, we want to solve for x and y. And one method for doing this is using something called Cramer's rule. Cramer's rule says that you can use determinants to solve a system of linear equations. Cramer's rule states that x can be found by taking the determinant of the x matrix and dividing it by the determinant of the coefficient matrix. And Likewise, y can be found by taking the determinant of the y matrix and dividing it by the determinant of the coefficient matrix. So let's set up our matrices. Let's start with the coefficient matrix. Well, the entries in the coefficient matrix are going to be the coefficients of our x and y terms. So A, B, C, and D. Our x matrix, the first entries are going to be E and F, and you can see that E and F are the constants of our linear equations. And then we have B and D. And then the y matrix, this is equal to A, C, E, F. So this is the setup for the matrices. So now let's insert our specific entries into these matrices. So what are the coefficients here? Well, this is a 1, this is a 1, then we have 1 over 40 and negative 1 over 60. So 1, 1, 1 over 40, and negative 1 over 60. That is our coefficient matrix. Now let's work on the x matrix. It starts with E and F. Those are the constants. So 400 and 0. Then we have B and D. And now for the y matrix. We have A and C, so 1 and 1 over 40. And then we have E and F, so 400 and 0. So now we have our three matrices, but if you look over here, when we solve for x and y, we actually need the determinants of these matrices. A determinant is a real number associated with a square matrix. So let's say we have the matrix with entries A, B, C, D. If I want to find the determinant, I'm going to multiply the entries in the main diagonal, so A, D, and then I'm going to subtract the product of the entries in the other diagonal, so CB. AD minus CB, this will give you the determinant. So let's solve for that here, for the coefficient matrix. Well, we take the main diagonal, so 1 times negative 1 over 60 minus, then we have the product of the entries in the other diagonal, 1 over 40 times 1. So we have 1 times negative 1 over 60 minus 1 over 40 times 1. And when you work this out, this is equal to negative 5 over 120. So that's the determinant of the coefficient matrix. Now let's find the determinant of the x matrix. Well, we take the product of the main diagonal, 400 times negative 1 over 60, and then we subtract the product of the entries in the other diagonal, so 0 times 1. So when we work this out, we get negative 20 over 3. And now for the determinant of the y matrix. We take the product of the main diagonal, 1 times 0, and subtract the product of the entries in the other diagonal. So 1 over 40 times 400. So we have 1 times 0 minus 1 over 40 times 400. And when we work this out, we get negative 10. So now solving for x, we have the determinant of the x matrix. We solved for that here. That's negative 20 over 3 divided by the determinant of the coefficient matrix. That's negative 5 over 120. And when we work this out, this is equal to 160. So x is equal to 160. And now let's solve for y. We have the determinant of the y matrix. We solved for that here. That's negative 10. divided by the determinant of the coefficient matrix, that's -5 over 120. And when we work this out, this is equal to 240. So y equals 240. Now, what did these mean? What did these variables stand for? Well, let's see what x was. Well, that's the distance person A walked. So this is 160 meters for person A. So person A walked 160 meters. And what was y? Y was the distance person B walked. So 240 meters for person B. What did the problem ask for? How far did person A walk? Well, that's x. So 160 meters. And that's the final answer. Thanks for watching.